Okay, so one of the lessons the other day, I suggested that if we knew that the two lines that were being crossed by the transversal were parallel, which we do know, you can see it right here with those marks, that means parallel. And here it's written here that L is parallel to M. Then watch what happens, okay? If a transversal, this right here, intersects two parallel lines, L and M, then same side interior angles are supplementary. Same side interior, so 3 and 6 are on the same side on the interior of the two lines. They add to 180. And 4 and 5 are on the same side of that transversal in the interior of the two parallel lines. So 4 and 5 are also supplementary. Neat. That's really useful. We're going to use that, and we can take this postulate and prove things now that we know this. The measure of angle 3 is 55. Which angles are supplementary to angle 3? How do you know this? Neat. Watch what we know. First, by definition, a straight angle measures 180. And where do we see straight angle compared to 3? We see it right here, and we see it right here. So if the measure of angle A plus the measure of angle B equals 180, then A and B are supplementary, so they're asking which ones are supplementary. So 3 and 2 are a linear pair, and 4 and 3 are a linear pair. So if we know that, so it says 180 minus 55 is 125, so any angle that measures 125 is going to be supplementary to angle 3. And angle 4, by definition, of a straight angle is going to be equal to that. Yeah, and same thing is true with angle 8. These are same side interiors, which is what we just had on that postulate in the last page. Okay, so we know that that measure of angle 8 is 125 as well and is supplementary. What else do we know? We know that angle 6, by the vertical angles theorem, because we know 8 is supplementary to 3, and these are congruent, so that also must measure that same thing. And what else do we know? We know that angle 2 and angle 4 are, because they are vertical angles as well. And we also know that because these are a linear pair. So if we start out knowing this one piece of information, we can find out all of those other angles. Neat. Okay. Let's see what you have to do here for yours. So if you did that last audit problem, you would have seen that, yeah, if you have two parallel lines cut by a transversal, the 8 angles that are formed, 1, 2, 3, 4, 5, 6, 7, and 8, you'll know them all if you know the measure of one of them. And that's pretty neat. Now, what are the relationships for these alternate interior angles? Like so, 4 and 6 are going to be congruent. 3 and 5 are going to be congruent. And it makes sense because this is a linear pair, right? And this is same side interior. So since they both sum to 180 with angle 4, 5 and 3 must be the same amount. Okay? Corresponding angles theorem says that, and remember, corresponding angles are in the same position. So if this is in the top left of that, this is in the top left of that. They're corresponding, and they're going to be congruent. 2 and 6 are going to be congruent, 3 and 7, 4 and 8. You want to take some notes on these and know that because we're going to apply this thinking. Now here's some proof of this. You're given that these two lines are parallel, so we've got this transversal now, and what we're trying to prove is that angle 4 is congruent to angle 6. And I just referred to this in the last slide, but if we did it as a two-column proof, the lines are parallel, that is given to us. We also know that measure of angle 3 plus the measure of angle 4 sum to 180. They are supplementary angles. You could also say definition of a linear pair. And measure of angle 3 and measure of angle 6 also sum to 180 because they are same side interiors. Okay, so what we can then do is by the transitive property of equality, we can say that if this is equal to 180 and this is equal to 180, then this and this are equal to each other. okay? And then subtracting away the measure of angle 3, subtraction property of equality, we have this statement, and if the measure of angle 4 is equal to the measure of angle 6, then angle 4 is congruent to angle 6. Definition of congruence. So that proves that alternate interior angles are congruent. Okay, let's see what a proof would look like if we were given that line A is parallel to line B, and we want to prove that angles 1 and 8 are supplementary, 1 and 8. You could call those same side exterior, and let's see what we've got here. First of all, that is given to us, okay? From there, what can we say? Well, we know that angle 1, an angle that was given to us here, is corresponding angles with angle 5, and we know that corresponding angles are congruent when the lines are parallel. If the lines are parallel, corresponding angles are congruent. They have to be parallel. But we do know that because they told us that, and we also see these marks here, okay? Now, that means that their measures are equal. Congruent angles have equal measures. We also know that 5 and 8 are supplementary because they're a linear pair, right? Angles that form a linear pair are supplementary. So given that, we can then say, okay, if we know that, then we know that the measure of angle 5 plus the measure of angle 8 equals 180, and that's what supplementary angles do, right? Now what? Well, we also know that angle 1 and measure of angle 1 plus the measure of angle 8 equals 180. How do we know that? See if you can figure this out before I say it, okay? How do we get from here to here? Well, this turned into this. How did this turn into this? Well, look, it says that they're equal amounts, and so we can, by substitution, we can just substitute that in, okay? And if we know that their measures are equal, then we know that the angles themselves, I'm sorry, not if their measures are equal, but if their measures sum to 180, then the angles themselves are supplementary, because that is what supplementary angles do. Definition of supplementary angles. Yep. By the way, as we go on, you're going to be proving these step by step, and you'll be able to do it. You'll write down things you know, and don't be too intimidated by them. The more you see them, the more you know what's going on. Try this. So you actually proved this theorem in the second got it problem, and that is that alternate exterior angles, alternate sides of the transversal but on the exterior of the parallel lines, are congruent, okay? Two transversals intersect parallel lines, the alternate exterior angles are congruent. And if you know the measure of one of the angles formed by two parallel lines in a transversal, we can use everything we know to find all the other angles. And I suggested that earlier. Let's see where we go from this. So what are the measures of angle 3 and angle 4, and which theorem or postulate justifies it? Well, let's first look. We have parallel lines here. We have parallel lines here. Neat. Okay. Well, we can use those in concert and what you might want to do sometimes is make a sketch where you only have the relevant information. But if we know that this is 105, okay, and we know all the lines are parallel, then we can say, okay, well then we would know that here to here, 3 is their alternate interior angles if we were talking about lines P and Q, yeah? And same thing here, we would know that these two are supplementary because if these are the parallel lines, they are on the same side interior if this was the transversal, okay? So let's see how they describe it here. But since line P is parallel to line Q, right here, then the measure of angle 3 by the alternate interior angles theorem is also going to be 105. And as I just said, since lines L and M are parallel, then the measure of angle 4 plus this 105-degree angle must sum to 180, same side interior. These are the two parallel lines, so it's on the interior on the same side of transversal Q. And so we can do a little bit of math and find out that that's 75 degrees. Try this one. So this one might seem a little wacky to you at the start because there's this extra line and it looks confusing, but imagine if this line wasn't here for a second and you could see that these are two parallel lines cut by a transversal, and this angle right here, that's 80, and this whole thing right here would then be same side interior angles, and they need to sum to 180. Okay, so what could we do with that information? Well, here we know that this y plus 40 is one of the angles, and the other angle here, 80, they need to sum to 180. Same side interior angles are supplementary. If you simplify it, you get this, and then when you do the subtraction property of equality, taking that away from both sides, you get y is equal to 60. Pretty straightforward, actually. You've just got to be able to see these two angles together as making this angle up, which is the same side interior with this other angle, 80. Okay? Give it a go with this. See how you do. Okay. Hopefully this all made sense to you, and you can find out if it did by doing the lesson check. Sometimes it feels like it makes sense until you try and do some problems, then you realize, oh, actually, I'm still a little confused. So doing these problems, it has a lot of value. So do them, check your answers.